Alright, so this is take two. We're going to be talking today about Siemens statement list. I guess the IEC term is instruction list, but yeah, in Siemens they call it a statement list, or STL. We're going to be working in TIA Portal version 16 on a Windows 10 machine that's running in a VM. Okay, so what we've got here is a function block that might do like analog stability. So we take an integer in and we compare it either for a set amount of time or a certain number of PLC scans and see if that value has stabilized, and if it has, we write it out. So let's put these two side by side, and we've got in ladder our first network. We're going to take 0 and we're going to move it to an output that we have called stabilized input. And what this does, it initializes a value to make sure we don't get any garbage or anything out of it. The equivalent in a statement list would be we're going to load a 0 and we're going to transfer it out to stabilized input. And then in STL we're going to start our jump list. So we take this input byte called mode, and we're going to use that to determine where in this list we go. So the equivalent, or close to the equivalent in ladder, would be to, in our second network, we're going to have a rung, and we're going to say if our byte value equals 0, we're going to take our raw input, compare it to the previous, use that to turn on a timer that we're driving with this preset value for our preset time. And if that completes, we're going to move our raw input to our stabilized input. So the somewhat equivalent in statement list is we're going to do this compare right here, and we're, instead of doing this instruction here, that's taken care of in the jump list. So we're going to say raw input and previous value, and we're going to have that set this value stabilized. That's a temp. And then we're going to take our raw input, shove it into our previous value, so we update it, and then we're going to take our preset value, that's our timer value, we're going to shove it into this temp, and we're going to take that temp and plug it into our timer. In ladder, we were able to take preset value and directly plug it in, but I think behind the scenes the compiler is doing some extra work in order to make that happen. Then if our timer is not done, we're going to do jump conditional, and we're going to go up here to end, and at end we just had a block end, so it's going to leave our function block. Okay. So then let's check out the next network. The next network is count based. We're going to say if we're telling it to do count based mode, which that comes from the jump list over here in STL, does the same thing. We're going to check to see if our value is stabilized. We're going to transfer our raw input to our previous value. And then we're going to say, if we don't have the value stabilized, we're going to jump to reset. So reset takes 0 and shoves it into the counter value, and then we jump unconditional to end. So no matter what, then we're going to jump. So same thing, if it's not equal, then we're going to move 0 into our counter value and leave. Then if the value has stabilized, we're going to jump to counter. In counter, which is similar to what we got going on right here, we're going to say, we're going to take our counter value and our preset value and see if our counter is completed. We're going to do a compare, and that's what we're doing right here. And then, depending on whether our counter is completed or not, if our counter is not completed, we're going to jump to increment. we're going to take our counter value, we're going to add 1 to it, we're going to shove it back in the counter value, we're going to jump to end. If it has completed, like right here, we're going to jump to right, we're going to take our raw input, we're going to shove it into our stabilized input, and then we're going to jump unconditional to the end. So there's a few more extra steps, but a lot of these were for clarity. I'm sure people can chime in and make this go a little bit smoother, a little bit easier. So let's do a quick thing with time. So I have both of these blocks are pulling their input from this raw input here. So if I put in a 22, well, let's set our mode to 0. Okay, see that lit up? Now we're doing our jump list and we're telling it to come through here. That means our RLO is active and we're running power through that network, or through these spots. So I'm going to tell it to do 22. So if you see, we're going to wait 10 seconds and our timer is going to make, we'll break through the STL one a little bit more here in a second. After 10 seconds, our power came on, enabled us to get the move through. Let's see what this looks like here. I'm going to give it a 14. So we should see our power come on. We're going to move these through. We're going to start our timer, and we're going to have, this is going to allow us to jump to end until we have timer completed, and then we'll be able to bypass this jump conditional, and we'll be able to go to move our raw input out. So right now we're jumping to the end instead of writing out this value. If you noted it's gray, that's because we don't have power flow through there yet. Now we have power flow, so we're not going to do our jump to end, and we're going to allow it to do this load and transfer. Okay, let's do the count-based network. Shrink this for a minute. So, if we tell it we're in mode 1 and we're not equal, we're going to reset our counter if our raw input doesn't match our previous value. Then we're going to take, if it does match, we're going to take our raw input does match our previous value, but our counter isn't made, we're going to increment our counter. If our counter has been made, we're going to move the raw input out to the stabilized input. So let's test that one out so you can see that real quick. Until it mode 1, so that energized. Now this will only come on for 1 scan, so we probably won't be able to see that, but we'll be able to see this run for 10,000 scans, and then greater than 10,000 scans we'll do that. So the counter's counting up. It's made, then we can write out. So let's take a look at what that looks like in a statement list. We may not be able to squeeze everything on the screen. Let's see if we can. Now we're pretty close. So the big thing to look for is we're not going to see our reset counter because that's only going to come in one scan. But we can see our jump to case increment, and we'll see this come on while we're counting up, and then we're going to see this come up. We can move the screen down and tap. And this will come up when we go to write out. So let's go ahead and change this. Change it back to 14. Oh, I didn't change my mode. Let's change that to mode 1. There we go. Alright, we'll change it back to 12 so we can see power flow through. So, we're counting up. When that's complete, this counter complete, it's going to come on. And then that's going to make us jump down to here. If you'll notice, this is gray. Now it's lit up. Now this is gray. That means we're bypassing this area here, and we're coming down to here. We make all our conditions, and we jump to end. So that's pretty much that. Source code will be available if everybody wants to see it. Oh, in the ladder program, in the ladder function block, we have we're moving our raw input to our previous value. I have that down here, but we didn't really need to do that because we take care of that here, and we also take care of that there in network 2. So I did want to take a second to talk about what the a few small differences in what's going on here. So this instruction lets us read the scan time of a OB, and we have an OB set up for the ladder, and we have an OB set up for the STL. And right now they're both running. It's hard to see them both at one time, but let's see if we get a screenshot. And what the So in this instance, when I took that screenshot, the ladder was taking 12 microseconds to run, and the STL was taking 8 microseconds to run. So that's, what, 50% faster? So that's kind of a big deal. The STL stuff runs faster. But to be fair, let's see if we can go to our call structure. Got my there we go. Have my little recording bar in the way. So we have the ladder uses less memory, and I'm going to bet that's because I created a couple temps for handling data and that sort of stuff. Probably a slicker programmer than me could get by without using that stuff, and then you wouldn't have to use as much memory. It does run faster, even though it uses just a little bit more memory, and I would venture to say you could probably get by running less memory too if you set up your program correctly. So like I said, source code will be available if you want it. Just send me a message, and if you want to do further research, or if there's areas that you feel like you could improve on. I guess maybe I'll take one more second and talk about this jump list. So what we're doing is we're taking the value of this byte, and then that tells us where to go at in the jump list, whether it's the first option or the second option or the 0 option. I think the one end here, that's always going to be the default, but these other two. That's 0 and 1. So you could have theoretically like 255 jumps, and then just go all over the place, do a lot of things like that. So that'd be another place to use it. Or if you have a set of instructions you need to run in a certain order, but you don't need like a full-blown graph or a full-blown ladder sequence or anything like that. Something that's treated more as a black box and not edited. Okay, well, I hope you guys enjoyed the video, and thank you for watching. Bye.